Hello and welcome to my channel. Remember, I am doing maths in science, and this morning specifically I want to do percentages. By the way, I hope you're still revising and keeping positive. Thank you for so many of you who have left comments for me. I have even had a call all the way from Kent, and I've had lots of people say to me online, how do they can they find my link, and the fact that the videos actually helping their youngsters to revise. Please, if you have any questions, don't hesitate to ask. Those who have asked me questions, I've tried to answer. And if you ask yours, I'll answer as well. So really quickly this morning, this is a typical calculation question in science. This is from the AQA chemistry paper 1. That's the assessment papers that have been released by the AQA exam board. This is a question in chemistry, and it's C1. Now, if you look at this question, it says figure 2 shows the structure of an alloy. And a student said to me, what's an alloy? Just as a quick overview, an alloy is a mixture of two or more metals, sometimes mixed with other materials. That's an alloy. It's a mixture of metals. You can also mix other non-metals with it sometimes to make it strong. The whole point of making alloys is to combine the properties of two metals. It's a very quick example. If you know, iron is a very strong metal, but it rusts easily. If you were to take aluminium that doesn't rust very easily, but not as strong, if you were to combine them as an alloy, you have a very strong material that would combine the property of the strength that you have in iron and the non-rustiness of aluminium. That's just to give you an example. That's how we also have gold-plated and silver-plated metals and that we use for jewelry and things like that. So that's an alloy quickly. But this particular question that I'm focusing on is in terms of how to work out the percentage. Because on the other section of the question, it says, what percentage of metal X is in metal Y? Now, what you have to do, metal X, they have only two atoms there, these two red ones, and then you have to carefully count how many of the Y that you have. On the paper is 25 of them, but I have just drawn this quickly this morning without counting, so I'll just count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31. So I have drawn a total of 31. Or okay, so you need to work out the percentage of metal X. So as you have 2 of that and 31 of that, you have a total of 33. So what you do, the one that you're asked to work out the percentage of, you pop it over the total and you multiply it by 100, because percentage means out of 100. And remember, you allowed a calculator. So I am doing this to always prove to you that you allow the calculator, or remind you, you allow the calculator, and we use a calculator. So we can do 2 times 100 is 200 divided by 33. So 200 divided by 33, if my calculator would allow me this morning. Yes, it's doing it. All right, there you go. It's going to give us 6.06%. I'm going to rub off the other numbers there so it's very clear. 6.06%. The question did not say whether to leave it to one significant figure. And remember, I did significant figures. If you were asked to reduce this to just 2 significant figures, it would be 6.1. Because you would need to reduce that to 1, and that would be 6.1. But if you were asked to reduce it to just one significant figure, then it would just be 6.0 or 6 for short. If you were not told specifically, this question does not say specifically, you just leave it like that. Lastly, another question, as I remember, that was asked on this paper was, what makes this alloy stronger than the normal metal? If it was just metal, why would this new alloy be stronger? And the answer to the question is because these atoms have different shape and they have different size compared with the normal metal Y. It therefore means that it will reduce the ability of metal Y atoms to slide over each other. So it will stop it from sliding over each other. That way, it would keep it in place or in position and make it a stronger metal, because the sizes of the metal that have been mixed into it and the original metal are different. Now, from just answering those questions, it's 3 questions by talking about what an alloy is, doing the percentage calculation, and answering the importance of alloy. You can rake in a good 5 marks from just that question. And it's really that simple. It's a new day, it's a new week. Whatever you do, keeping positive and keep revising. Like I say, I always mention you in my prayer, those that are watching, all the young people that are writing their exams, please, parents and carers, let's continue to give them support. Let's continue to encourage them. Tell them they can do it. They've got everything that they need to do well in this GCSE exam, which is just, in fact, is so close now. My students are taking their first paper on the 15th of May. It's really around the corner. But I know that they can do it. I believe in the young people that I work with. They are the next generation. We've got to do everything to equip them to be able to take over. Have a very beautiful day, and God bless you.